Good morning, students. Welcome to the class of Mathematics. So, how your studies are ongoing? That good. So, today we will take a topic on heat, that is expansion of solids. Okay. So, students, what is expansion of solids? So, what do you understand by that? Okay. Any metal, expansion is always happened in metals. Okay. Any metal, when its temperature is increased, it's expanded. Okay. The volume, the area, the length of that particular solid is expanded, right? So students, let me tell to you that this expansion is at all the three levels. What are that? That is linear expansion, uh, that is linear expansion, linear expansion and linear expansion, and another is superficial expansion. Means superficial is your areal expansion across the area. Okay, this expansion is across the length. Linear expansion is across the this expansion is across the length. Okay, and with the same increase in temperature, when the area increases, that is called areal expansion. Okay, expansion in the area will be observed. And one is the volume expansion, right? What is that? Volume expansion, that is called linear superficial and volume expansion. So here the expansion in volume is observed. Okay, now students, we know that what is the difference between length, area and volume. Okay, there is a formula in thermodynamics where L at particular T, length at particular temperature, length length at particular temperature can be correlated at length at 0 degree plus 1 plus alpha t. You know what is alpha here, students? Alpha is the coefficient of thermal, here linear expansion, right students? Similarly, the area at particular temperature T can be written as area at 0 degree temperature plus 1 plus beta T, right? Where beta is the coefficient of areal expansion, right? Similarly, volume expansion. For volume expansion, we'll take volume. We can say volume at particular temperature T. When the temperature is increased by particular, suppose the temperature is increased. Okay, this is increased to T, and initially it was 0. So it is called T0, and this is T, right? So here it's 0. This is the T. So T minus, if delta, the change in temperature is T minus 0, which is equal to T, right? So this we quoted over here, this T, this T, right? So similarly, we are discussing about the volumetric expansion, that is equal to V at 0, and it will be multiplied by 1 plus gamma T. Okay, this is gamma. Okay, where gamma is, what is it? This is the coefficient of volumetric expansion, right students? Now, for density, you know what is density? Density is mass per unit volume. Okay, for density there is some change. Okay, this formula is not followed over density. For density, it's always seen that when we are increasing the temperature, density decreases. Okay, so we can say density decreases with increase in temperature. That is, here the relation will be like this: T0 will be equal to density at increased temperature into 1 plus gamma T. So this we need to keep into mind, students, that these are the some basic formulas which we will use to solve the numericals based upon these. Okay, so this is one, this is another aerial, this is for volumetric expansion, okay, and this is for density, how it is related. Now students will try to take some to try to solve some numericals which I have already noted it down. They are good examples. Okay, a metal is heated from 0 degree centigrade to 500 degree centigrade and its density reduces to 1 by 0.027 of its original density. What is the coefficient of linear expansion of this solid? So students, they are asking for the coefficient of linear expansion. Okay, coefficient of linear expansion. So it will not be linear expansion because coefficient of linear expansion. Yeah, here coefficient of expansion will be there. It's not linear because uh, the density will be always there in the volume part. So this is a misprint in the question. So forget about the linear. What is the coefficient of expansion of this solid? So now we are knowing the formula. What is that? The formula is that d0 equal to dt, this one. We will use this formula over here. Okay, d0, and this will be question number 1. Let's say this will be question number 2. For solution 1, what we will write? d0 equal to dt into 1 plus gamma t. Gamma, this is the coefficient of expansion, right, for volume case, right? So density at 0, a metal is heated from 0 degree to 500 degrees centigrade. Okay, so the 0 degrees centigrade to 500 degrees centigrade, so temperature will be that it's a difference of 500. Okay, so t0 equal to 0 and t at 500 is 500 degree centigrade, right? So d density at 0, they are asking for the density which is reduces to 1 by 0.027. That means we can say that the final density will be equal to 1 by 0.027 of d0. So we can write it as d0 equal to dt, and dt, what dt? Dt will be, we can say that dt equal to 1 by 0.027 of d0, right? So we will just put this value over here. Okay, put this value over here. So we are getting d0 equal to 1 d0 divided by 0.027. As per the question, I have marked it into red that dt, density at particular temperature T, will be equal to 1 by 0.027 of d0. Okay, so it will be like this, into 1 plus gamma into T, and T, T, it's a 500 degrees temperature, because T is, you can calculate it like this, 500 minus 0. Okay, so after getting it, after solving this, you can go ahead like this, 0.027 go into the LHS, and it will be 1 plus 500 gamma, and this will be equal to, um, gamma will be equal to, this is the coefficient of expansion. This is will be equal to 0.027 minus 1 divided by 500. So this is your answer, students. This is the coefficient of expansion in this case, because it's negative, because it will come in a negative sign, because the coefficient of the density is decreasing with the increase of temperature. Okay, so definitely, so we are getting the answer, right? So students, we are now we have solved this question number 1. This is solved. Okay, now we are coming to question number 2. What is that? An iron tire to be fitted on a wooden wheel. A wooden wheel, have you seen a wooden wheel in a wooden cart? This is of a cart. Okay, on a wooden cart, a metal strip is inserted over there. You know how that is done? That is done by giving a heat, increasing the temperature of the metal, that is iron. When it expanded, just it is put over the wooden wheel, and then it, when it shrinks, it fitted over the wooden wheel, and that is used in the wooden cart or horse cart or whatever. Okay. So here an iron tire is to be fitted on a wooden wheel of a cart. Wooden wheel diameter is 100 centimeter and iron wheel diameter is 5 centimeter less. So we can say that 5 centimeter less means 100 minus 5 equal to 95 centimeter is the diameter of iron, and this is the diameter of wooden wheel. Okay. So this will be like this. This will be, we can say, this will be like this. This is a wheel. Above this, and above this a wheel, and this is not very circular. Don't worry, students, I think we're getting the concept. Okay. So we can say it like this. Okay. This is, we can say it like this, that this is iron ring, or iron iron length, which is inserted circularly, and green one is the wooden. Okay. Is the wooden wheel. Right, students, right. So here we know that what we have to calculate. Let us see. Iron tire to be fitted on wooden wheel of a cart. Wooden wheel diameter 100. Iron wheel diameter, we get it. How much should be the temperature of tire to be increased? So we need to identify the T, where alpha, the coefficient of linear expansion, is given 12 into 10 to the power minus 6. You know, it's a coefficient of linear expansion. Okay. So here in this case, you know, what is the length, what is the uh, length of the circular ring? It's equal to 2 pi r. You know, students, it's a diameter. It's a diameter of any circular path or any circle. So we can write it as pi into d. And for wooden wheel, the length will be pi into d, which is equal to pi into 100 centimeter. 100 centimeter. Right, students? This will be 100 pi. And similarly, iron wheel, iron wheel need to be heated with T temperature. Okay, need to be heated with T temperature. Okay, so we will just come to the question and solve it, and let us write it that here T temperature to be given for expansion of iron ring. Why this need to be given? This need to be given so that with application of this temperature, the iron ring expanded, and it will just allow, and it will fit over the wooden wheel, and when it shrinks, it fitted over there, right? So what we are discussing over here, that iron wheel, what is the diameter of the iron wheel? It will be equal to length of the circumference, that is equal to pi into d. And you know, students, we have discussed over here, that's it's 95 centimeter here, 95 centimeter. So diameter is 95. So the iron wheel length will be 95 into pi, right? This is diameter of iron, and this is diameter of wood. 100 pi. Now students, you know that for a linear expansion we apply the formula for linear expansion. What we will write? L at particular temperature T will be equal to L at 0, length at 0 into 1 plus alpha T. Okay, where alpha is the coefficient of linear expansion. This is the coefficient of linear expansion, right students? So L at T, you know what is that? After expansion, the expansion is happening on the wheel, happening on the iron wheel. Okay, and only iron is a metal and it has the property to expand when heated. Okay, so for iron, L at temperature T will be 100 centimeter, you know, because unless and until it's gone to 100, it will not set over the wooden wheel. And L of 0, its initial will be 95, and it will be 1 plus alpha is given over here as 12 into 10 to the power minus 6 per degree centigrade. It will be 1 plus 12 into 10 to the power minus 6, right students? Take it as a curly bracket and into T. What is that? We need to identify it. So this we need to solve. So let us do it. This will be equal to 100 by 95. No, it's not, don't do like this. Just multiply the RHS. 100 equal to 95 plus 12 into 95 into 10 to the power minus 6 T. So here all things are known except T. So we can calculate it very easily. 100 minus 95 by 12 into 10, 12 into 95 into 10 to the power minus 6. This will be equal to temperature. And when you will solve it, 5 by 12 into 95 into 10 to the power minus 6, which will be equal to 515, 515, 519. That will be 19 into 12. 19 into 12 equal to 391,228. Okay, this will be 1 by 228 into 10 to the power minus 6. This is equal to temperature which is required in degree centigrade. So students, this when we apply this temperature, okay, then we can say, so we are writing this solution as, so when T equal to 1 by 228 into 10 to the power minus 6 degree centigrade is applied, then iron ring fits over wooden wheel. So thanks students. Just I will say, just like and subscribe my channel. For any queries, put up into the comment box. We'll try to answer it as soon as possible. And I will always say, keep on studying. Definitely you will succeed one day. Happy learning. Bye bye.